Okay. Yesterday I said the next step in prediction is if I give you the reaction in words, or the reactants in words, okay, that you would be able to write them out, identify the reaction type, and predict the products and balance. So this is the last step, okay, in our predicting products of a reaction stuff. So what I would like you guys to do is not do 1 or 2, okay, but I would like you to try 3, 4, 5, and 6. Okay, 3, 4, 5, and 6. Write them out in formula form, balance. Okay, so you're writing out the reactants, predicting the products, and balancing. Right now, but the difference is now you're getting it in word form. Okay, does that make it more difficult?
Yeah.
Not necessarily. It's more work, and you have to watch out because you have to be on the lookout for drops and swaps in your reactants and special elements in your reactants now. You only had to look for them in the products before. Now you have to check for them on both sides. That's really all that's different. Okay, so I'm going to give you a few minutes to try those, and then we'll walk through them together. Okay, so on number 3 here, we have magnesium solid. Okay, so that means magnesium as an element. Mg, is magnesium special? No. All right, it reacts with nitrogen gas. Is that special? Yes. Okay. What kind of reaction are we looking at? It's a synthesis reaction, right? Okay, so this is going to make an ionic compound. Okay, Mg with N, and that will have to drop and swap. Okay, so a -3 and a +2, so we're looking at Mg3 N2. Right, and then we need to balance this simply by putting a 3 in front of the magnesium. Questions on that one? All right, and then we're taking the product of that for number 4, okay, magnesium nitride. Okay, and we're mixing it with water. Now there's 2 ways to do this one, and I'll show you both. If this was on a test or quiz, I would have both obviously on the key. Okay, if you wrote water like this, okay, you're going to get a slightly different answer than if you wrote water as H2O. Right, so we'll have a look at that. So we've got a double replacement reaction here. Hydrogen acting as the metal in water, magnesium acting as the metal in magnesium nitride. So we're going to swap those. Magnesium will end up with hydroxide, and hydrogen will end up with nitrogen. All right, so I've just made 2 new ionic compounds. What do I have to do with them? Drop and swap. All right, so hydroxide's a -1, magnesium's a +2, so we're going to have MgOH2, okay? And then on here we're going to have a -3 and a +1, so we're looking at H3N.
What if we did water as H2O? Is that just wrong?
Okay, so we're going to balance, okay? And here's how that's going to go. We're probably going to want to start with balancing our magnesium here. Okay, so we're going to try the 3 here, okay, for magnesium, which is going to give me how many hydroxides? 6. Okay, so I'm going to put a 6 here to balance my hydroxides. That gives me 6 hydrogens. So I'm going to go here, okay, and then I can look back at my nitrogens and know that they are balanced. Okay, so now the reaction is good. As I said right before I started this, I'm going to show you the other way to write this reaction. Okay, Mg3N2, okay, is reacting with water, written as H2O. Okay, nothing wrong with writing it this way. It's just the products look a little bit different. Okay, so now still a double replacement reaction. Hydrogen and magnesium are going to switch places, but now magnesium ends up with oxygen, hydrogen ends up with nitrogen. We still have H3N here. Okay, that doesn't change, but MgO is different than MgOH. Okay, so we're going to have, this is a -2, this is a +2, so that's fine the way it's written. Now I need to go ahead and balance. All right, so I'm going to put a 3 here, okay, and then I'm going to put a 3 here, and then I have to put a 2 here, and that makes my nitrogens work, and I'm done. All right, so it could be right either way, and as I said before, both ways would be on the key if it was on a test or quiz. How many people have done number 5? All right, so look at that one too then. Okay, so I've got iron 2 sulfide. What is the Roman numeral telling me?
The charge.
It's telling me the charge. Okay, so I've got Fe as a 2 plus with sulfide as a 2 minus, so that compound is fine, swapped and dropped that way. It's reacting with oxygen gas. Is that special? Yes. Okay, what kind of reaction am I looking at? Single replacement. Okay, oxygen is a non-metal. Who's it swapping? It's, yeah, switching places with sulfur. So that means iron will end up with oxygen. Sulfur will wind up alone. Do I have any specials? Yes. Okay, and then I need to drop and swap this. -2 plus 2, so that compound is fine. All right, now I need to balance the whole reaction. Probably better start with sulfur. Put an 8 there. That gives me 8 irons, so I got to put an 8 there and a 4 there. Okay. Everybody all right with that one? How many people have done number 6? Okay, I'm going to give you guys a couple more minutes to finish up number 6 because it's got a really important thing that we need to quickly review that happens in it, and then I'm going to have you guys try these prediction ones on the boards as groups. So with number 6 here, I've got molybdenum sulfide. Okay, so molybdenum is MO, and its charge is +6. Okay, and it's with sulfur, whose charge is -2. So it's an ionic compound, which I need to drop and swap. When I drop and swap, though, I get 2 and 6. What do I need to do with those two numbers? Lowest terms. That's what I wanted to point out. We need to remember when we're doing this that when we drop and swap, we always put it in the lowest terms. Okay, so this is not going to be written as MO2S6. It's going to be written as MOS3. We always reduce ionic compounds to the lowest terms. We talked about that quite a while ago. Okay, so just reminder of that because obviously that's pretty important if you're going to get the balancing right, okay, on this reaction, or you just get the reaction right, period. Okay, so it's going to react with oxygen gas, which is O2. Okay, single replacement reaction where oxygen and sulfur will switch places. Okay, so I'm going to have MO with O and sulfur by itself. Okay, as S8 again. I need to drop and swap this one, and it's the same situation. A +6 with a -2. Okay, we're going to end up with Mu3. Okay, for that compound, and then S8, and then we have to go back and balance everything. Okay, we got some big numbers here. Okay, probably going to have to put a 3 in front of this to get 24 sulfurs, and 8 in front of this to get 24 sulfurs. Okay, and 8 in front of this, and then a 12 in front of that one. Okay. All right, I'm going to number you off, and then I need you to go to the correct board that goes with your number.